Hey guys, here's my solutions for the June 2022 AS Paper 2 for AQA. Hope you find them helpful. So for question 1, it says, can we find the integral of 12x cubed? So we just have to remember to raise the power by 1 and divide by the new power. So if we do that, it would be 12x to the 4 divided by 4. 12 over 4 is just 3. So it'd be 3x to the 4, and we have to remember to add a constant when we're doing an indefinite integral, an integral without limits. So that makes it the second option. Then for question 2, it says, given that cos theta minus 20 is equal to cos 60, which of the following is a possible value for theta? Well, the way to think about this is just to quickly draw yourself a cos graph. So a cos graph looks something like this. And cos 60, let's say that's about here. So we're trying to find another value where the cos graph is the same. So it would be this one over here that we're interested in. And remember, the cos graph ends at 60 degrees. And if this is 60 here, this value we must be after would be 360 minus 60, or 300. So we need theta minus 20, theta minus 20 to equal 300, which is just going to be 320 then. So now for the next question, it says, a curve has equation k root x, where k is a constant. Can we find the second derivative, d2y by dx squared, at the point 4, 2k on the curve, giving our answer as an expression in terms of k? So we're going to have to differentiate. So the first thing I would do is express the curve as a power of x. So if we have y equals k root x, well, that's really just kx to the half. So then our first derivative, dy by dx, would be a half k x to the minus half. And then our second derivative, d2y by dx squared, would be, multiplying by the power again, it would be minus a quarter k x to the minus 3 over 2. And then we need to evaluate the second derivative specifically at this point they gave us, so the point 4, 2k. So plugging in 4 into our second derivative, so that would mean d2y by dx squared at our point 4, 2k is going to equal minus a quarter k 4 to the power of minus 3 over 2. And that all that is minus a quarter k, and then it would be, the half would imply a square root of 4, so that would be 2, and then the minus 3 would mean it would be 1 over that cubed. So it would be times 1 over 2 cubed. 2 cubed is 8, and then 8 times 4 is 32. So we'd have minus 1 over 32k as our answer. Okay, and now for question 4, it says the equation 9x squared plus 4x plus p squared has no real solutions for x. Can we find the set of possible values of p? Fully justify your answer. Well, the question's asking about the roots of a quadratic, really. So if there's no real solutions, that means there's no roots of our quadratic. And the discriminant tells us about the roots of a quadratic. If there's no roots, we know the discriminant, b squared minus 4ac, has to be less than 0. So let's just take note of what our a, b, and c are. A is 9, b is 4, and c is p squared. So substituting those into our discriminant, we'd have 4 squared minus 4 times 9 times p squared. 4 squared is just 16. Sorry, that's less than 0. And then 4 squared is 16. 4 times 9 is 36. So we'd have minus 36p squared is less than 0. So now we're left with a quadratic inequality. Whenever I have a quadratic inequality, I like to plot the graph. So if I just solve that quadratic for its roots, the 16 minus 36p squared, we can plot the graph easily. So let's just have a little aside over here. So 16 minus 36p squared equals 0 if we want to find its roots. That's going to leave us with p squared is going to be equal to 16 over 36. which is going to leave us then with, if I take the square root of that, p would be plus or minus 4/6, or plus or minus 2/3. So then we can plot this quadratic of 16 minus 36p squared. If I draw some axes here, then the roots are going to be at plus or minus 2/3. So let's say that's minus 2/3 there, and plus 2/3 there. The graph's going to do something like this. And we're interested in where this quadratic is strictly less than 0. So we want to take the set of values for p from the left of minus 2/3 and from the right of 2/3. So we can express that in set notation as the union of two sets. So the first set, let's say p, the set of p values where p is less than minus 2/3. And then we're going to take the union with the set of values of p where p is greater than 2/3. And that would be our answer for the set of values for p. Okay, now question 5, it says Kaya is investigating the function f of x equal to 2x cubed minus 7x squared minus 12x plus 45. Kaya makes two statements. Statement 1 is that f of 3 equals 0. Statement 2 is that this shows that x plus 3 must be a factor of f of x. Can we state with a reason whether each of Kaya's statements is correct? Well, the first one's easy enough to check. We just have to substitute 3 into the function and check if it comes out as 0. So f of 3 would be 2 lots of 3 cubed minus 7 lots of 3 squared minus 12 lots of 3 plus 45. Substituting that into a calculator, we have 2 lots of 3 cubed minus 7 lots of 3 squared minus 12 lots of 3 plus 45. That does come out as 0. So our first statement is indeed correct. Statement 2 then says this shows that x plus 3 must be a factor of f of x. Well, that's not true, because f of 3 being equal to 0 would actually imply a factor of x minus 3 for our function f of x, because if you plug in 3 into x minus 3, that factor comes out as 0, and the whole function would come out as 0 if it's a factor. That's what factor theorem tells us. So the second statement is incorrect. Then for part B, it says, can we fully factorize f of x? Well, now we can, because we know that a factor is x minus 3. So we can start with algebraic long division. So we're going to divide x minus 3 into our function of 2x cubed minus 7x squared minus 12x plus 45. So we start by taking the highest power of x left to be divided, the 2x cubed, and divide it by the highest power of x in our divisor. So 2x cubed divided by x gives us a 2x squared. So I'm going to write 2x squared in this column. And then we multiply 2x squared back through by our divisor. So that's going to give me the 2x cubed back. And then I'd have minus 6 lots of x squared. And then we subtract. So minus 7, sorry, the 2x cubed cancel. And then minus 7 minus minus 6 is going to leave us with 1 lot of minus x squared. And then I like to write down the next term again. So minus 12x, I'll just put that down there. And then we repeat the process. So we take minus x squared and we divide by x. So that would give us just minus x. Then multiplying through again, x times minus x gives us our minus x squared back. And then minus 3 times minus x, that gives us plus 3x actually. So then subtracting off, that's minus 12 minus 3 is minus 15x. And I'm going to write down the plus 45 again. And repeat the step one last time. Minus 15x divided by x would give us minus 15. And multiplying through, we'd have minus 15x plus 45. And subtracting off, we do get a remainder of 0, just to check that we've got it actually right. So far we've realized that f of x now can be written as x minus 3 times 2x squared minus x minus 15. And then it says fully factorized. So we'd like to search for some factors for this. So I would start with thinking, well, it's going to be 2x and x. And then how can we solve that? So factors of 15 could be 3 and 5. Would those work? Yeah, so if I put minus 3 here, that would give me minus 6 lots of x. If I put a plus 5 there, that would bring me back up to minus x. So that would be the full factorization of f of x. Question 6 now says, an online science website states, to find a dog's equivalent human age in years, multiply the natural logarithm of the dog's age in years by 16 and then add 31. Let's just summarize that first. So it's saying dog age in human years is equal to 16 times the natural log of dog age in dog years plus 31. And then part A then says calculate the equivalent age to the nearest human year of a dog aged 5 years. So that would just be 16 times the natural log of 5 plus 31. If we plug that into a calculator, so 16 ln 5 plus 31, that gives me 56.75, or to the nearest human year, that would be 57 years. Then part B says a dog's equivalent age in human years is 40 years. Can we find the dog's actual age to the nearest month? So we're going the other way now. So we're going to say the dog's age in human years is 40, and that's equal to 16 times the natural log of the dog's age in dog years plus 31. So I've got a logarithmic equation to solve. If I just take away 31 at first, I'd have 16 ln of the dog's age in dog years would be 9. So that would mean then the natural log of the dog's age in dog years would be 9 over 16. And then just using the definition of a logarithm, we'd say the dog's age in dog years would be e to the power of 9 over 16. So if we put e to the power of 9 over 16 in our calculator, that gives me 1.7551. But it's asked us to find the age to the nearest month. So we get 1 year, which is 12 months, and then we've got to add 0.7551 of a year. So 12 times 0.7551 gives me 9.06, so another 9 months to the nearest month. So in total, it would be 21 months for the dog's age in dog years. Part C then says, explain why the behavior of the natural logarithm for values close to 0 means that the formula given on the website cannot be true for very young dogs. Well, if we take the natural logarithm of the dog's age in dog years, and we look at the graph of that, it tends towards minus infinity, actually, as the dog's age tends towards 0 in dog years. So that doesn't make any sense, right? You can't have negative infinity age in human years, because that's what our overall function would tend to. So we'd say, well, the dog's age in human years tends towards minus infinity. Sorry, minus infinity, as the dog's age in dog years tends towards 0, which just doesn't make any sense. So yeah, that would be enough. Question 7 says the expression 3 minus root n all over 2 plus root n can be written in the form a plus b root n, where a and b and n are rational, but root n is irrational. Find expressions for a and b in terms of n. So to write it in this form, we're going to have to rationalize the denominator. So we're going to take our starting fraction, 3 minus root n, over 2 plus root n, and to rationalize that, we're going to multiply by 2 minus root n over 2 minus root n. So doing the multiplication, 2 times 3 is 6, and then 3 times minus root n is minus 3 root n. On the bottom, we have, next we'd have minus root n times 2 would be minus 2 root n. And then minus root n times minus root n would just leave us with plus n. Then on the bottom, we know the cross terms are going to cancel, so we just have to worry about 2 squared, which is 4. And then root n times minus root n, which would be minus n. So simplifying up, in the numerator, we're going to have 6 plus n minus 5 lots of root n all over 4 minus n. So we can split the fraction up to have it in this form. So that would be 6 plus n over 4 minus n and minus 5 root n over 4 minus n. Sorry, 4 minus n. So that would mean A is 6 plus n over 4 minus n, and B is minus 5 over 4 minus n. Okay, next we've got question A. It says triangle ABC has sides of length m minus n, m, and m plus n, where 2n is greater than 0 but less than m. Angle A is the largest angle in the triangle. Explain why A must be opposite the side of length m plus n. So to help us with this, let's just draw a quick diagram. So if I draw a triangle, and let's label this side A and the other two B and C. And we can see the angle at A really depends on the length of side B. So to make angle A bigger, we'd like a bigger side for BC. So to make it the largest angle, we need to make it the largest side. And checking the sides, well, m plus n definitely would be bigger than m, and m minus n if n and m are both positive. So m plus n must be opposite because m plus n is the largest side. Cool. Then it says, part 2, using the cosine rule, show that cos A, which is equal to m minus 4n, show that cos A is equal to m minus 4n over 2 lots of m minus n. Well, we can fill in our diagram now if we know that m plus n is the side opposite angle A, and then the two remaining sides must be m minus n and m. It doesn't matter where we put either on either side. So using the cosine rule, let's just state the cosine rule first. So c squared equals a squared plus b squared minus 2ab cosine c. So the important thing to remember is that the c in this formula corresponds to an angle at a corresponding opposite side. So for us, we want to think about a and the side opposite that, which is m plus n. So we're going to have m plus n squared then equals the sum of the two remaining sides, so that's m squared plus m minus n squared. That'll be minus 2 lots of m minus n times n times m times cosine of our opposite angle, so cosine of A. So our expression here is for cos A, so we want to rearrange for cos A. So let's start by just moving this to the left and this to the right. So that would leave us with 2 lots of m minus n times m cos A would equal m squared plus m minus n squared minus m plus n squared. Now let's divide by two lots of m minus n times m. So cos A would then be equal to m squared plus m minus n squared minus m plus n squared all over two lots of m minus n times m. So we already have something like our denominator, but we just need we're going to need to cancel this somehow at some point. So that's pretty close. But looking at the numerator, I can already tell some things are going to cancel if we started to expand these brackets. Excuse me. Because I know I'd get an m squared from here, and m squared, well, there's already an m squared there. So that's going to subtract away, and some other things will most likely happen as well. So let's start by just expanding the brackets now. So cos A would be m squared, and then expanding these brackets, we'd get m squared, and then we'd have m times minus n, which is minus nm, but there'll be two lots of that, so minus two lots of nm. We'd have a plus n squared from minus n times minus n. And then I'm going to leave this last bit in brackets because we need to subtract everything in here. But if we expanded that out, we'd have m squared plus two lots of nm plus an n squared. And then that's all over our denominator still. So two lots of m minus n times m. And some things are going to cancel here. So we can cancel off this m squared with this m squared here. And we've got an n squared is going to cancel as well. This n squared will cancel with that guy there. So let's condense down the terms that we have remaining. So now we'd have cos A would equal, we've just got an m squared on the top, and then we'd actually have minus four lots of nm. And then that's all over 2m minus n times m still. But we can cancel off a factor of m from the top and bottom here, which does leave us with the m minus 4n over two lots of m minus n, which was the desired result. Good. Now it says that 8b, you are given that BC is the diameter of a circle, and A lies on the circumference of the circle. The value of m is 8. Calculate the value of n. So let's draw a diagram for that. So here's a circle. And then just using what they said, let's say our point A is on the circumference. And we'll have points B and C forming a diameter. And then let's draw our triangle in. And then we remember, so angle A, we had that expression from before. Cos A was m minus 4n over two lots of m minus n. Let's write that down. That was m minus 4n over two lots of m minus n. So we can use that, and we know actually that m is 8, so let's include that. So cos A equals 8 minus 4n over two lots of 8 minus n. Right. And then let's include our sides on the diagram. So one side was the side opposite angle A. We knew that was m plus n. So that would be 8 plus n left then. The other sides were m minus n and just m. So this side is, this side would just be 8, and this side would be, it was m minus n, wasn't it? Yes, m minus n, so 8 minus n. And there's one other piece of information we can use here. So what we have is a circumscribed triangle where all 3 points sorry, where one of the sides is a diameter. So that's a circle theorem, meaning this angle here at the circumference must be a right angle. So we actually know angle A then is 90 degrees. So cos of 90 is 0. So this expression we have must just equal 0. So 8 minus 4n over 2 lots of 8 minus n must equal 0. And then we can actually just worry about the numerator. If the numerator is 0, then the whole fraction is going to be 0. So if we set 8 minus 4n equal to 0, 4n would equal 8, and then n would equal 2. Question 9 then says, the diagram below shows the graph of y equals x squared minus 4x minus 12 and y equals x plus 2. Write down 3 inequalities which together describe the shaded region. So first let's identify which curves are which. So the straight line is obviously y equals x plus 2 and the quadratic is the curve. So y equals x squared minus 4x minus 12. And the first thing I would do is, let's start by just thinking about, well, y being less than x plus 2, that would define everything below our straight line. So all this. And then if we included y being greater than the quadratic, so y being greater than x squared minus 4x minus 12, that would then limit that region we had, which again was just all this, but we have to only take points that are bigger than the quadratic. So that would be just all the points that lie in here. But we have to find a way of getting rid of all these points. But the thing we notice about all those points is they're all less than 0. So the last thing to add in to get rid of those would just be y must be greater than 0. Good. Then part B says, find the coordinates of the points A, B, and C. Well, A and B are just roots of our quadratic. So let's find those first by setting y to 0. So we'd have x squared minus 4x minus 12 equals 0. Does that factorize? 6 and 2 factorizes that. So we'd have x minus 6 and x plus 2 equals 0. So that would give us solutions of 6 and minus 2. So that must mean A is minus 2, 0. And B must be 6, 0. Okay, then to find point C, that's going to be where the line intersects the curve. So we're going to solve simultaneously the quadratic and the straight line. So that would be x squared minus 4x minus 12, and then substituting the y would be equal to x plus 2. To solve this, let's just bring everything to the left and set it to 0. So that would be x squared minus 5x minus 14 would equal 0. And the nice thing about this is we already have a solution for this, because A is also a solution, which would correspond to a root or a factor, sorry, of x plus 2. So x plus 2 must be a root, meaning that the last root or factor would be x minus 7. So x would equal 7 for our final point C, and to find the actual y coordinate of C, we can plug it back into this. So 7 plus 2 would be 9. So point C must be 7, 9. Question 9c says, can we find the exact area of the shaded region? Well, let's bring back the diagram so we can start looking at the shaded region again. So that shaded region ultimately is curved because it's bounded by BC, which is the quadratic or piece of the quadratic. So we're going to need an integral at some point. And what I would do is draw that line there, and then we've created a triangle, which you can see there, there, and there. And then we could find the area of that triangle and subtract this area bounded by the curve on the x-axis. So let's do that. Remember, we have the points A, B, and C from previously. So A was minus 2, 0. B was what was it? Let's check. It was 6, 0. And then C was 7, 9. Let's check that also. Yeah, 7, 9. Good. Okay, so let's start by finding the area of that triangle. So the area of the triangle is going to be given just by a half base times height. The base goes from -2 to 6, which would just be a base. Sorry, not -2 to 6, -2 to 7, because it's that point there is the end of the triangle. So -2 to 7 would be a base of 9. So a half times 9. Then the height goes from 7, 0 to 7, 9, which is another 9. So half times 9 times 9. 9 times 9 is 81. So it's going to be 81 over 2 for our triangle. Then we find our this curved area here. So curved area is going to be an integral from 6 to 7 of our quadratic. It's bounded by the quadratic and the x-axis. So yeah, x squared minus 4x minus 12 dx. So performing our integral, we'd get a third x cubed. We'd get minus 2 lots of x squared and minus 12 lots of x. And we still need to evaluate the limits of 6 and 7. So writing out the workings for our limits, we'd have a third of 7 cubed minus 2 lots of 7 squared minus 12 lots of 7. And then subtracting the bottom limit, we'd have a third of 6 cubed minus 2 lots of 6 squared minus 12 lots of 6. And if we put that all into a calculator, we'd get 13 over 3. So then our shaded area, remember, is going to be that triangle minus the curved area we just found, or the area under the curve, rather, we found. So shaded area is equal to 81 over 2 minus 13 over 3. If we put that into a calculator, 81 over 2 minus 13 over 3 would give us 217 over 6. And an important point here, guys, is that we leave our final answer as a fraction because it says find the exact area. Question 10 then says, a bottle of water has a temperature of 6 degrees centigrade when it is removed from a refrigerator. It is placed in a room where the temperature is 20 degrees centigrade, and then 10 minutes later the temperature of the water is 12 degrees centigrade. The temperature of the water, T degrees centigrade, at time T minutes later, or T minutes after it is removed from the refrigerator, may be modelled by that equation given there. Part A says, can we find the value of A? So the first thing is to identify what information we have about this model from the question. So the main thing is that it starts at a temperature of 6 degrees centigrade. So how does that relate to the model? Well, that's telling us that capital T is going to equal 6 when little t equals 0. The second thing is we're hoping that it would tend towards room temperature. That would make sense for a bottle of water. So we'd want big T to tend towards 20 as little t tends towards infinity. And then 10 minutes later, the temperature of the water is 12 degrees centigrade. So we also know that big T equals 12 when little t equals 10. And something to watch out for here, guys, is just make sure you pay attention to units, because they like to trip people up. But everything is actually given in units in the question also, as well as in the model. Good. So finding A, well, the thing to use to find A will always be when t equals 0, because it's going to make, if you sub t equals 0 into there, that's going to get rid of having to worry about k. So we know 6 is going to equal 20 minus a e to the 0. E to the 0 is just 1. So A then is going to equal 20 minus 6, which is 14. So A is 14. Then it says calculate the value of k, giving your answer to two significant figures. Well, to find k, then we're going to use the other piece of information. Oops. The other piece of information, t equals 12 and t equals 10. So using that, we'd have 12 equals 20 minus our value for a, which is 14, e to the minus k times 10, so minus 10k. So that's an exponential equation to solve. So let's first just rearrange for our exponential. So 14 e to the minus 10k would equal 8. Then e to the minus 10k would be 8 on 14. And then using the natural logarithm, minus 10k must equal the natural log of 8 over 14. Or k equals minus 1 over 10 times the natural log of 8 over 14. And then using a calculator to check the value, so minus 1 over 10 times the natural log of 8 over 14 comes out as 0.055961. So 0.055961 ... and then we want to round it to two significant figures. So the first significant figure would be this 5 here, and then the second significant figure would be here, but that's going to go up one if we round to there, because that 9 is going to round up, so it would be 0.0562 sig figs. Part C then says, using the model, estimate how long it takes the water to reach a temperature of 18 degrees centigrade after it is taken out of the refrigerator. So that's pretty similar to the calculation we did a moment ago, but let's actually type it. Let's actually use the model and work out what it is. So we want the temperature to be 18, and that's going to equal 20 minus 14 e to the minus kt. I'm just going to leave it as k now because it's quite an annoying value to keep writing out. And we'll use our k that we found in a minute. So rearranging for t again, the same process we did a minute ago, but I'll just repeat it. So 14 e to the minus kt is going to equal 20 minus 18, which is 2. And then e to the minus kt is going to equal 2 over 14. So minus kt would be the natural log of 2 over 14, or t would equal minus 1 over k natural log of 2 over 14. And I'm going to use my unrounded value of k that I had in my calculator. Still, I haven't got rid of it. So t would be minus 1 over my answer that I got earlier times the natural log of 2 over 14. And that gives me 34.77. Oops. And I'm going to round to three significant figures as it hasn't told me otherwise. So that would be 34.8 to three significant figures. Good. Explain why the model may not be appropriate to predict the temperature of the water 3 hours after it is taken out of the refrigerator. Okay, well, I would probably check and see what the temperature of the water is, but is predicted to be from the model first. So if we use the model, we'd have capital T for the temperature would be 20 minus 14 e to the minus k times what was the time? 3 hours, and that's so they're trying to capture out with the units, like I said. So 3 hours in minutes, that's 180 minutes. So it'd be times 180. And then we're going to use our value of k, which I'll bring up again in my calculator. So plugging that in the calculator, I do actually get a value quite close to 20 degrees centigrade. I get 19.999 degrees centigrade. So, I mean, that seems kind of reasonable, but perhaps something to consider is 3 hours after it was taken, maybe the temperature of the room might have changed. Or perhaps, I mean, it's very close, but maybe you should say it should definitely be at 20 degrees centigrade. It would definitely match the temperature of the room after 3 hours. I'd say let's go with the first one. So maybe the temperature of the room would probably change, or likely to change. Question 11 then says, which of the terms below best describes the distribution represented by the box plot in figure 1? So we can choose even, negatively skewed, positively skewed, or symmetric. Well, a giveaway is that the left tail of the box plot is longer than the right tail, which would mean it's negatively skewed. Then question 12 says, Shelley organized an activity weekend for 15 groups of 10 people. She decided to collect a sample to obtain feedback about the weekend. To collect the sample, Shelley selected 2 groups at random and then interviewed each member of these 2 groups. State the name of this sampling method. So the first thing is that the population she's sampling from has been divided up into groups or segmented. And then she's randomly selecting people from each segment or cluster. So that's an example of cluster sampling. Question 13 then says 2 random samples of 12 NOx emissions in grams per kilometer were taken from the large data set. One sample was taken from the 2002 data and the other sample from the 2016 data. The sample data are shown below. The mean and standard deviation of the 2002 sample are 0.122 and 0.137 respectively. Can we find the mean and standard deviation for the 2016 sample, giving our answers to 3 decimal places? So we just have to use the formulas for the mean and standard deviation. So the mean is just the sum of the data, so the sum of x over n. And if we use our calculator to calculate that, we'd get 0.026. And then to find the standard deviation, the standard deviation is the square root of the mean of the squared data minus our mean squared. So first, if I use my calculator to calculate the mean of the squared data, the sum of x squared over n, that gives me 0.00141. And then we're going to take away 0.026 squared from that, which gives me 4.65 times 10 to the minus 4. And I need to square root that answer, which gives me 0.02, how many decimal places was it? It was 3 decimal places, so 0.0216 for my standard deviation. Then 13b part 1 says, City claims these samples show that on average the NOx emissions across all makes of car in all areas of the UK have fallen by over 75% between 2002 and 2016. Show how City's claim of over 75% has been obtained. So we need to calculate basically the change in the average NOx emissions. So the change in the average of our NOx emissions. So the new mean is 0.026 and the old mean was 0.122. So if we want to calculate the percentage change, that's going to be equal to the actual change. So that would be 0.122 minus our new mean of 0.026 over the original mean, 0.122, and then times that by 100. If we do that, we get 78.6 or 78.7%. And they said over 75%, so that is indeed greater than 75%. So for 13b part 2, it says, using your knowledge of the large data set, make 2 comments on the validity of City's claim. Well, City's claim was quite quite a broad scope. So it said, let's see, it said makes across all makes of cars and in all areas of the UK. So that's 2 comments we could easily bring them up on, because in the large data set, not all makes of car are included. So not all makes included in the large data set. And also not, what words did they use? Not all areas of the UK are included in the large data set. Question 14 says, Ying Tai visits her local gym regularly. After each visit, she chooses 1 item to eat from the gym's cafe. This could be an apple, a banana, or a piece of cake. She chooses the item independently each time, so that's an important piece of information. The probability that Ying Tai chooses each of these items on any visit is given by the data here. For any 4 randomly selected visits to the gym, find the probability that Ying Tai chooses at least 1 banana. So this is going to be a binomial problem with counting a discrete set of events. So for the first one, if I say x is the number of bananas chosen, then x would have a binomial distribution with a sample size of 4 and a probability of picking a banana of 0.35. So we're going to calculate the probability of at least 1 banana. So that's the probability x is greater than or equal to 1, which we could do as 1 minus the probability x is equal to 0. And if we use our calculator to calculate that, so the probability x equals 0 would be 0.1785, so that would leave us with 0.9215. Or to 3 significant figures, it would be 0.922. (14b) then says what's the probability that she picks the same item each time. So that would be either picking 4 apples, 4 bananas, 4 cakes. So that's going to be just 0.2 to the 4 for the probability of 4 apples, plus 0.35 to the 4 for the probability of 4 bananas, and then plus 0.45 the power of 4 for 4 cakes, which would come to 0.576 to 3 significant figures. 14c then says, what's the probability of picking an apple twice and a cake twice? So first, what's the probability of picking 2 apples and 2 cakes? Well, that would be 0.2 squared times 0.45 squared. So 0.2 squared times 0.45 squared. That would give us 0.0081. And then we have to think, okay, well, there's how many ways can she pick 2 apples and 2 cakes when she's selecting 4 items? So that would be there's 4 entries and she can pick between 2 options. So that would be 4 choose 2. So 4 choose 2 is 6, and our final answer would just be 6 times our 0.0081. Which would be 0.0486. Okay, question 15 now says we've got the discrete random variable x is modeled by the probability distribution given below, where k and c are constants. Can we find the probability that x equals 3 in terms of k? So if we want to find the probability x equals 3, that corresponds to this section of our distribution. So if x is 3, we'd get the probability x equals 3 would be k times 3 squared, which would just be 9k. Then for part B, we've got the probability x is greater than or equal to 3 is 3 times the probability x is less than or equal to 2. So let's form an equation using that. So the probability x is greater than or equal to 3 would be the probabilities of 3 and 4 added up. So that would be 9k, and then 4 squared is 16, so another 16k. That must equal 3 lots of the probability x equals 1 and 2. So if we use this for 1 and 2, we'd get c and 2c. So that'd be just 3c, and then multiplying out, you'd have 9c. So we'd have 25k must equal 9c. And then we also know that all the probabilities have to add up to 1. So if I add them all up again, that'd be c plus 2c plus 9k plus 16k must equal 1. So we'd have 3c plus 25k must equal 1. And then 25k is just 9c. So let's substitute that. 3c plus 9c must equal 1. So 12c then equals 1, or c equals a 12th. And if we go back and use this to find k, so k would be 9c over 25. So dividing that by 25, so it would be 1 over 12 times 9 over 25, which would give us 3 over 100 for k. So for the last question, question 16, it says, it's believed that a coin is biased so that the probability of obtaining a heads when the coin is tossed is 0.7. So let's make a note of that. Probability of heads equals 0.7. Assume that the probability of obtaining a head when the coin is tossed is indeed 0.7. Find the probability of obtaining exactly 6 heads from 7 tosses of the coin. So that's a classic binomial problem. So if we say x is the number of heads tossed, then the distribution would be x is binomially distributed with a sample size of 7 and probabilities of success of 0.7. And we're looking for the probability x equals 6. So using our calculator, the binomial PD function, where x is going to be 6, our sample size is 7, and our probability of success is 0.7, we get 0.247 to 3 significant figures. Find the mean number of heads obtained from 7 tosses of the coin. Well, the mean of a binomial distribution is just the sample size times the probability of success. So 7 times 0.7 would be 4.9 for a mean. Then 16b, it says, Harry believes that the probability of obtaining a head for this coin is actually greater than 0.7. To test his belief, he tosses the coin 35 times and obtains 28 heads. Carry out a hypothesis test at 10% significance level to investigate Harry's belief. So first, let's write down the distribution that's relevant for Harry's test statistic there. So that's going to be the binomial that we had before, except with a sample size of 35 now. And the probability of success is 0.7. The null hypothesis, we're assuming, is that the probability of heads is indeed 0.7. And Harry's test hypothesis is he believes the coin is actually more biased in favor of heads. So P is greater than 0.7. So that's a one-tailed test. and it's an upper tail test. So for his test statistic of x equals 28, we need to find the probability x is greater than or equal to 28, which would be 1 minus the probability x is less than or equal to 27. So if we find that using the binomial CD function on our calculator, so 27 for x, n is now 35, and p is still 0.7. So we'd get 1 minus 0.86735 ... which is going to leave us with 0.13265. So the probability of getting ahead is actually bigger than 10%, because that's like 13.2%. So the probability is greater than getting, probability of getting 28 heads or more is bigger than 10%. So we don't have any evidence to support Harry's claim. So we reject the test hypothesis in that case. That's it for this video, guys. Hope you found it helpful. If you're looking for some one-to-one tuition, you can check out my website using the link in the description. Thanks, and I'll see you in the next one.